Hello. Had a very interesting week. Busy at work as usual, but we've had some terrible weather. And it's been so bad that this weekend I'm not even going to be able to make it up to the mountain. But luckily for last week, I went up there and pulled down the alternator and all the parts I could find, which wasn't that much. So I got the alternator there. Noticed some corrosion. I have to clean it up. And there is the plate for the 403. I'm not going to use that. From the blade that I copied from this in steel, this is a 7-inch diameter radius. So what I'm planning on doing is making a hub that will be 7 inches diameter and radius, and see how that works out. So got a little bit of work today. I'm gonna design the hub here on SolidWorks, then clean up some of this rust and everything here. And I noticed when I did this, I had the terminal block outside, so I don't remember how I connected this. I'll have to look in there to see exactly how I connected to the winding. So I'll be tearing this apart and getting into it because this wire is going to be way too short, because I'll need to hook on to, well, I don't know, it might not be too short. It might actually fit if I put the terminal block right behind it. So, well, let me get working on the hub and let's see what we can get from there. After a little bit of work and just sort of figuring out which way I was going to do it, I got it right here. So I have exported it and I am going to cut it out. Now the holes for the hub and to hold the windmill, I will not actually have the machine cut them out. I will actually have the machine put a little dot there, and then I will drill those out on the drill press so that the holes are really clean. So let's take it over the machine and cut it out. Well, I looked around, found an old piece of aluminum scrap. I was thinking of using steel, but for right now, all these testing purposes, I'm just going to make it out of scrap. If I find something of a thickness that seems good enough, I'll use that. So I'm just going to use this, and got to go through and load everything up now. Just making my marks right now. All right, now should be getting close to cutting. There she is. I got the plate done. I noticed that there's some issues with cutting the aluminum on the table on these bigger holes on the input, even though I set it to come from more inside and then work its way out, tend to not do a very good job on the aluminum. And I've also realized there's limitations to this plasma machine on how accurate it is. So I might end up having to redoing the fact that might end up just having to do this on a lathe, because I don't like how inaccurate, as you would say, it is. Today also I had to drill by hand because the drill press is being used for something else. So there was that, but I still noticed that wasn't exactly happy with everything. But for a test piece, it's pretty good. It gives me an idea. I can sort of put pieces together and see what I'll come up with. So I can still use this and see exactly how far off it is. But it looks like probably gonna have to be using the lathe to make these. So I just really don't like just the way it cuts the aluminum. Cuts steel much nicer. So I got to figure out why my circles are just not like how I'd like them. Interesting. All right, well, let's get back over to where the blades are and see how they fit up. Well, putting it together, it doesn't look too bad, actually. I just noticed that the blade end is too close to the center of the hub for the nut. I did take a look at this one right here, and it shows it's like and put them out a 1/4 inch farther. So when I was duplicating this one here, I was duplicating their pattern, assuming that this radius that I estimated would give me where these would go relative to the hub, but it seems to me that shows that it's a little closer. So that means I basically have to move these out about 1/4 inch. Well, let me do some more looking. I've got the new modifications on the plate. I'm not gonna cut any of the small holes, only the big holes with a plasma. I'm also gonna turn down the current, try it with a little bit better precision. So instead of the 100 amp tip, I'm gonna put a 50 amp in it. So I've set everything up here, and I've got to change the tip and then send the process. After redoing the tip on that, and everything's set, so I guess I will start it. A bunch of holes to mark out. Sort of hard to see the little holes that it marked for me. So, but I did find that my center hole, which I thought was 5/8, is actually a 17 millimeter. So I need to get a 17 millimeter, or I guess a 43/64 drill bit for that center. But I'll have to pick that up to do this. But I'm going to cut 2 of those hubs because I figure I'm using them to sandwich in the blades. So let's just wait and get it finished cutting and see what we get. Still not perfect, but much better using the smaller tip. So much more pleased with that. Now I gotta drill the I'm gonna use a very small drill bit and drill out all the points that should be holes. Well, I finished drilling that, except for the center hole, which has to be 17 millimeters. So I got to go get a drill, and actually using the machine is better than I first thought on our first plate, using a 50 amp rather than the 100 amp. Plus I did a little more due diligence by using a very small drill bit to pilot, and then slowly using larger drill bits, and everything seems to be close enough that this would be usable. So I'm going to basically sandwich the blades in between. So gotta go get me a drill bit. So hopefully I can get it today and continue. Otherwise I'll be continuing this on another day. I'm finally back, and I'm back on the wind turbine project. And the previous footage I'd gone up to grab pieces of the wind turbine, and there's my original blade. I just plan on using that for a test, but it's going to be on the final project, so I will try that out. I cut these two more. They're just rough right now. I got to work these so they're the same as this, and then I'm going to figure out some way to weigh them to make sure that they all three weigh the same, and then after that, then see how much more of an effort it would take to balance them if I need to. And I'm going to use I have two of these. Initially I was going to use one and try to make some other bracket pieces, but I just realized if I use two of them and sandwich in the blades, it works really nice. So let me just finish off on getting these two ready, and then we will completely assemble a hub, except for I'm still waiting for my drill bit. I've ordered a drill bit, which is 17 millimeter, and it's been taking a while to get here. So I can't mount this today on the turbine, but at least I can mount all the blades on, and then we'll look at more of the guts of the generator itself. I've got all the blades all taken care of. Got them bent to where I want them. Got the various tapers and everything on it. Did it all by hand. So I did notice that, see if I look at these, it would be, well, actually now that I'm looking at it, it's hard to tell, but this one right here I made first, and when it was cut out, I believe I used a 100 amp tip on the plasma cutter over there, and these two are more precise, and they were used a 50 amp. So this one probably has slightly less metal because of the pressure of the plasma. Probably took a little bit more off, so this is probably the lightest of all three of them. I'm still going to use it for right now. I can always I'll try to work out some way for balancing later, but I'll bolt these on. We'll see how it looks, but we won't be able to put it on the shaft because I don't have that drill bit. Amazing that in this even here at this shop we don't have that bit that I need, and I want that hole to be precision, so I'm ordering directly the 17 millimeter. But I figured I'd go on the AC, I think it's AC Delco. This is like was a really common alternator, which I took the diode pack out, put these wires in, so I had 3-phase out. I'm going to open it up and look at it, and it's been so many years I don't really know exactly how I tied the wires to the windings. So I'm going to figure what I have there, make sure it's good enough, and then probably have to put longer wires on it. But let's open it up and take a look. Looks like to me I've got a 5/16 bolts in this thing, so it should come apart rather easily. The biggest issue that I might be thinking about when I'm using these is the bearings. I've had this thing running before and the wind's up to 100 miles an hour and haven't had a bearing problem yet. Always the problem I'd have is I would burn out the windings. I'd produce too much power. So one of the ideas was I can either change the coils on the voltage and the current, put a current limiting resistor in line, which I usually don't like because you sort of waste a little bit of power. But sometimes in my situation, if you build enough of these, that little bit of waste is not a problem and saves you in the long run from damaging the alternators. Let's see, I believe it's all of that. See if I can get this thing apart. There we go. And that magnet's in there. Make it really, really hard to get apart. Oh, this one's done. In fact, I remember when now that I think about it, I remember putting this together and it snapped together so quickly it almost sliced my fingers. I'm gonna have to get me something else to help pull this thing apart. We got a couple screwdrivers. I was grabbing both the front housing and the outer coil assembly at the same time, so I'm separating those so I can take them apart in multiple pieces so I don't have to be fighting the It's got a little bit of corrosion on it. I'll probably want to paint it better and clean it up. There's my spacer. That. It's on there pretty good. Whew. These magnets are extremely strong. That right there. Oh, well, there's a reason I can't pull that out, because I've got the wires. Oh, I see. I can't remove this coil because I've got the wires. So, well, let me show you what we got. Looking down in here, you'll see right here where I've got the wires, and basically, now that I remember it, I made a terminal block. I cut this normally would have a diode pack there to rectify three-phase. It'd be 6 diodes in the pack. And looking at it, I've used some looks like 5/8 insulating material, and I made me a little terminal block in there so that the wires from here go right to the terminal, and then whatever wire on the back side goes through, each one goes through the holes to the terminal. And I didn't realize that I had done such a good job in there on that. I was wondering whether or not I'd done something rather quick or Mickey Mouse just to get it done quickly. And looking at it, I even have my antices on there. This was done quite a few years ago, probably over 10 years. more than that, probably about 15 years ago. So I'm going to clean it up, get all the corrosion off of it, and then I will reassemble it. But these are really easy because, well, at the time when I put it together, this is like standard windings that you could order, just go down to like Napa. They used to have a store in Tooele with a guy that would repair alternators and generators, and I could buy these coils from him for like between about 12 bucks a piece. I mean, there's not that much to them, and these are pretty simple. I mean, that's what I liked about it, because if I burn them out, I could just go down and grab them. They would sell them to you in like 12 volts, 24 volts, of all different types of the winding setups. And looking at it, I don't know if it would be all that difficult to wind them yourself. Probably have somebody custom wind it to a specific voltage range. And looking at this one, I'm not sure what this one was wound at. It's been way too long for me. Since I noticed the wires are very heavy on this one, it's probably more, doesn't produce as much voltage, more current. But I'm not exactly certain on that. I'll have to look at some of my other coils. So, and then this, there was like a company years back that put these together, and basically they took I believe the AC Delco parts and then put together permanent motor magnets in it, and those on that one there are super strong. In fact, the magnets are so strong, probably a little bit too strong for this. I mean, it works great if you're going at a slow speed, but when you like powering up full bore, this will produce a tremendous amount of power, if I remember right. I think it was almost like into I'm guessing 1,600 watts or something like that. And it's not a very big unit, so I don't necessarily want to push them to their limits. I like to run them like at 50%. I just you know, run them at 50%. They'll last like forever, and just build a whole bunch of them. So I'm going to clean this thing up right now, and then I will put it back together. I'm just going to spray paint a little bit of the sections that had some rust on it. Got the shaft taped off so I don't paint on the shaft. I got a little more corrosion on that. Looks like I'm going to have to take the coil out. Get that out. One thing I noticed about these coil packs, you can see I still have some tape here, and I painted the iron, is that this thickness of the iron that they use for the core is just a whole bunch of plates stacked together, and then they got these big long rivets holding it all together. Looking at it, I could probably almost make those plates. So you just have to make a whole bunch out of a sheet of metal to make one of the cores. But these are easy to get to, but just in the back of my mind, if I ever had to make one, it wouldn't necessarily be that bad or that hard with the plasma cutter. Not sure if I can get that precise on our big one. Might require like a smaller plasma cutter, but if you had something like that, you could actually make your own iron core, and you can wind them by hand. So one of the things always when you're building stuff like this and you want to be as independent as possible is like, how much can you like repair? Now there's only so much time in the day to actually work on things, so it's nice to get things pre-made, but get things that are pre-made that are repairable forever. That is the real trick. And this right here, if the windings burn up, you can by hand rewind it for whatever thickness you want, and you can wind it for the various voltages. I'm not going to get into that right now, maybe later on, but like I said before, one of the issues I have is maybe the bearings in these cases won't just be the hold up to par for prolonged use. But looking at the way it's designed, it's very, very simple. You could almost make something like several pieces of pipe and then run it in the lathe to get this exact diameter here, and you can almost stack these coils. You're gonna have like multiple magnet units on it. But one thing I was thinking about would be that you could have a magnet to generate the power for the windmill, but when the speed gets really high, you could have another circuit and another standard coil like they used to use on the alternators, and kick that on to generate extra power and load down the turbine at the same time. So instead of actually having to, you know, close any shutters because you're spinning too fast, or trying to do some sort of technique, you could actually click on another field winding and simply stall out the blades, or stall it down to a speed that won't cause any damage. So I'm going to keep working on this right now, but it is interesting because I do not think it would be that hard for me to actually make my own case. It looks actually really, really simple. If I could find some aluminum pipe about that diameter, and then be able to just machine it, because aluminum's easy to machine, I can make several pieces and make them all like slide together, and then bolt it all together, and then bolt all the pieces together, which is basically all this is. And I mean, if you look at it, this is really simple. You simply got your coil pack that generates your actual power. You got the magnets that turn to generate the alternating fields to generate that power, and just a place to hook it in, and bearings on either side. All right, let's get this thing put together and see what we go from there. Took a little time, just real quick, got on the computer to look at how much tubing and pipe at approximately 135 millimeters, which is about 5 5/16 inches. Well, really, I guess a standard size I found would be this 5.5 outer diameter with a 0.125 inch wall with an inside diameter of 5.25. So that means basically with that inside diameter of 5.25, it has to be turned down until we have an inside diameter of 5.31. So that's not very much to take out. I mean, so we can cut different lengths of this pipe and sandwich it in with our coil, and then I can make flat plates that can hold bearings in. So I can put beefier bearings. I could even like maybe take this magnet assembly off and make a longer shaft to put maybe more windings. So looking at all this, we got a lot of things to do. Like I said before, I was going to put this together before talking about it, but I ended up starting to think about what it would be like to actually build the whole thing yourself now. And it seems like most of the parts, everything you would need to make a really good generator, was locally made with very little work or machining to have to do this. So I'm going to put that on the list to be able to build our own generators. Now, granted, I have not built any of these magnet assemblies, but they don't seem to be that difficult. So, all right, and back to what I just said before, I am going to get this generator put back together. Well, I put the generator back together. Just left the wires that I have there for now because I'll have to figure out what size I'll use later. But everything's all cleaned up and everything there, so it'll be easy to take it apart. Like I said, when I was sticking that shaft back in, it just jumps in there. So it's pretty scary putting it back together. And then I bolted all together the blades onto the hub, and so as soon as I get the drill bit for the center hole, I'll be able to bolt it on to the generator. Everything's there, and it's sort of basically it right there. Sort of a nice little setup. I figure that'll be all for today and this video. Still got more stuff to do on it. I figure I'm going to, as soon as I can get that 17 millimeter drill bit, which I ordered a while back, we can get this thing together. I will make a little test jig, and then we'll start to try to figure out some way to make sure it's balanced. So that's going to be some more working on this, but everything's coming along slowly, but coming along. Our weather has been pretty cold and overcast, so I still haven't been able to get to the fortress, but it's March is coming right up on here, so it looks to me like hopefully spring's going to hit and we can get doing some real building. So thanks everyone for watching, and everyone remember, if you like it, click on the like button, and if you're not subscribed, subscribe, and thank you so much. Have an awesome week.